Hi there everyone, welcome to part 2 of this tutorial on how to make a sort of bioluminescent tentacle system. This is where we got in part 1, and what we're going to build out in part 2 is something that looks a little bit more like this, adding in attractors like in this example here. So what we're going to learn is how to add some automation to the system, as well as adding multiple attractors in TouchDesigner. We're going to work with this system. This can be found in the tutorial that is on my YouTube channel, Bioluminescent Tentacle Tutorial Part 1. This is going to be everything that kind of leads up to this network here that we're working with. A very quick rundown of what's happening here is we have our input. In this case, what I've done is I've attached a switch because it can either be a sphere or a plane, if I put in the correct value. And this is going to go into a random attribute, which is basically setting this length. We're using, in this case, we're combining the color of this incoming image, and that's going to define the color of each tentacle and also the length. And we're using copies and noise, particularly the template attributes, to do a lot of the heavy lifting here. Now, before we get sort of started in making some additions to this network, what I want to do is I want to add in an interactive camera that we can use. To do this, we're going to go to this side panel here, the palette, and under Tools, we're going to drag in Camera Viewport. Now, I have made videos on how to use the Camera Viewport before, so if you are intrigued in the sort of behind-the-scenes extras to this component, go take a look at that. But for now, I'm just going to link it in, and all we have to do is drag it into our network, drag it onto our render, and use this as the camera. So we can see now we have this different view. I can go ahead and delete that original camera if I like, because it's not in use. And what I can do in the camera viewport, we can see that if we switch to panel, which we actually already are on, that has switched to this new view from above. I want to link my camera viewport to the panel. So under the camera viewport options, under camera, in this panel component, I'm going to delete this bit of text and put ... which is going to signify we're going up a layer. And now when I interact, I can actually move this around, which is super cool. I can also press the H key, and that's going to home my network here. For some additional control, I can right click and say open parent parameters. And right now we have just the left mouse button acting. So basically I can rotate this around a central point. If I right click, I can't do anything. And likewise, if I middle click and zoom, I can't do anything. So I'm going to turn on this middle and right click. So now if I hold my right click down and drag, I can position this in my XY plane. And likewise, if I hold down my option key and do a sort of middle mouse zoom, I can zoom in and out of my network as well. So that's the first thing I wanted to do. The second thing I wanted to show you is that this can actually be anything we like, really. So right now we're putting in this noise, but it could be like a movie file in. So let's do a movie file in. Let's start off with just this banana before changing some stuff up. We want to plug this into a fit, because if we remember what happened if we were not matching our resolution from this grid with the resolution of this top, we don't get a very good mapping of the color parameters. So I'm going to take this, I'm going to have my fit have 50 columns referenced, and we'll just copy this and do rows. So now it's going to change our image to basically match whatever our resolution of this grid is. So every grid point is going to correlate to a pixel. I'm going to set this to fit outside, and actually I'm also going to bring this into a null so it's easy to switch between things. I'll drag this up And now we can see that we have created something that's going to take our banana. Or let's change it to something that's actually maybe moving over time. Let's go and look at, let's use this one. So we can see now that the texture is being manipulated by whatever that movie is. What we can also do is we can add in a few post-production things to the movie that will make it appear sort of better in this view. So we can have a level, and so we can change a bunch of the characteristics in the movie. And I'm also going to insert a blur to smooth out some of that plane. And something else I'm going to do is just automatically do a half speed on the speed of that movie. And what we can see is that kind of makes the movie a little bit jumpy. So I'm going to also go in and interpolate frames and just keep it on interpolate frames. We can sort of play around basically with any input video that we like to create these sort of interesting types of patterns. I'll go back to that noise because I kind of like that effect. That was a bit of a long sort of intro to what we're going to do. I'm going to start adding in my attractors, and then we're going to look at some extra post-production-y things. For example, making these little trails that are just touching the top of each of our tentacles. Okay, so we have our network set up in a way that we like, and we're now ready to add in these attractors that are going to disrupt the sort of tentacle field a little bit. I'm going to zoom out and position this. And the first thing that I want to do is I want to create the position that's going to drive my attractor position. I'm going to create a noise chop and just drop it into my network. In the parameters window, I'm going to go to common, turn time slice off. I'm going to set for my channel X, Y, and Z. And then I'm going to go into here. I'm going to turn my period up to 5 for now because I don't want this moving super fast. I'm going to make a sphere pop. And for now, I'm just going to reference the X, Y, and Z in my sphere translate. I'll bring this out into a geo, so I should also be able to visualize that, not a geo text, a geo. And there we can see it's sort of interacting with the scene. Now, it's not going to be that visible because it's going to be just moving around my 0, 0, 0 position. So I'm going to amp up that amplitude a bit. Let's say 5 by, say 10. And what we're going to see is it's also sort of going to be offset. So it's going to also go below the object itself. So what I want to do is I actually want to bring this out to a math. I'll plug this into a null just to make things easier for us to work with as we keep changing stuff. So I'll just do null 2 and just copy that. Okay. What I want to do is I want to change the Z axis. So I don't want the object coming up quite so high. So what I'm going to do is under my common tab, I'll set my scope just to Z. And let's actually see if that does work. And what I will do is in range, I'm going to go from -10 to 10. I'm going to go from 0 to 10. Actually 0 to 5. And so this should ensure that my object is not moving below the surface too often. If I want to have something that's a bit more, got a bit more air on it, I'll just amp that up a little bit. And what I also want to do to make this a little bit dynamic later is I'm going to bring this out to a trail. And I'm going to do a chop 2 on this trail, so we actually can see the trajectory where this has gone. And I'll merge these together. But right now we just sort of want to see the trajectory of where our sphere attractor has gone. So this is great. We have basically like a visual right now for where our attractor is. And now we can start building out the actual traction component related to that sphere. We'll then look at how we might build multiple versions of these attractors and implement them. We're going to place our attraction component in this section of the network right after our manipulated lines. If we recall correctly, what we were doing is we initially made a line, then we copied all these lines and applied noise. And then in this math mix, what we're doing is we have a sort of a scale factor that essentially ramps between if we're applying the noise or not applying the noise to that tentacle. And what we can see here is as we go higher and higher up that component, we are mixing more and more. So if I put 0, we can see that we're just maneuvering these straight lines in terms of their depth. I mean, to be honest, in itself, this is kind of an interesting effect that you could utilize. And as we turn up that scale, and in this case, we were using a parameter called mix, we're able to mix between the straight line and the noise. So we want to put our attractor component after this section here, because in this section here, this is where we sort of do more of a post-production type thing and create these tentacle tubes around the lines. So we actually want to affect the underlying line before we start adding these tentacle tubes onto the top. And in terms of the attractor math logic, I'm going to be basing it off this video I made really early on when we were working with POPs and utilizing vector mathematics to pull our particles towards a force point. So we're going to kind of go and build this from scratch, but for folks that are signed up to my Patreon, I do have a very handy attractor component that you can download and use. This will be available alongside this network as well if you don't want to go through the steps of rebuilding that. So we have this attractor right here, and there are a few steps, but basically all we have to do is plug in the position data. So if I took this null 2, let's just link that up. We want parent 2. There we go. So now we should have an attractor that's linked to that second null. I'm going to turn off this noise animation for now so it's easier to see that in action. So we can see already how this orb is pulling the tentacles towards it, creating this sort of interesting effect. Okay, we're going to build this out from scratch. And the first thing we want to do is add a field pop right after this math. And the field pop allows us to create a field that we can manipulate. Here we have this radius value, so we can set the radius of our pull. I'm going to set it to about 3. Transition range and weight we can play with a little bit later. And I also want to move my transform to match where this sphere is going to be. So let's grab this and view it and just drag in those chop data positions. So now our field is going to be moving alongside our sphere. What we could do to quickly visualize that is let's add in a math mix, and this math mix will also be where we apply our attractor logic as well. But let's just do a quick little operation here and do A times B. So we're going to do P for our particle position times weight. And so we can see that the field is basically giving us a position in 3D space, and we can apply some kind of operation based on that field. So actually this is in itself kind of a cool effect. So you could use this for sort of various effects. And what we want to do is, rather than use this field as a multiplication to just see stuff in that field, we're going to use it to create attraction and repulsion using this math mix. So I'm going to just say none right now so we're not affected by anything, and let's build that out. I'm going to start out by creating a couple of uniforms. The first one is just going to be a float that is going to be my strength. So this is basically how strong this effect is going to be. Let's set it to 1.5 for now. And the second uniform I want to create is going to be my attractor position. I'm going to call it apos, and it's going to be a float 3 because we're going to have our x, y, z coordinates in there. So let's go in again. Let's do this view. Let's drag in our x, our y, and our z. You could also reference this from the field, but for me, I like to visually see where that data is coming from. So these are the uniforms that we want to create. The first operation we want to do is a subtraction, and this is part of getting the direction that we want to pull in. And so we're going to say apos minus p. So we're taking our attractor position and we're minusing the particle position from that value. And now I want to take that apos value and I want to normalize it. So I'll go and normalize that, and I'm going to call this result scope dir for direction. The next thing I want to do is I want to do a multiplication, and I'm going to do a multiplication multiplying weight by direction, and I'm going to call this scaled direction. So this is scaling that vector so that we get this push and pull. I also want to calculate a force of that pull based on where I am in my field. So I'm going to do another multiplication, and I'll say scaled direction multiplied by strength, and we'll keep that as scaled direction. And then I should be able to do A plus B, and so I'll do P plus scaled direction, and this should give us our final output, which is going to be our P. So basically we're adding our calculated direction force to our position. And right now I'm seeing an error, and I'm realizing that I've made kind of a mistake going through this quite quickly. And so the mistake here is we can see that error, combine block 0 can't write to uniform. So I've created these uniforms, so I've got strength and apos, and what I can't do is take that uniform and have it as a new result. So basically that uniform is kind of like a constant and it should stay the same. So I'm going to switch this to AP. I'm going to switch that to AP, and there we go. That should start out doing it. So we can see that we have this effect where we are pulling, which is not quite what we want at this point. So let's sort of play around a little bit more. So we can see the higher that strength is, the more radical the effect is. One of the things we can see is this is quite a drastic effect. And what we're going to do is we're going to go back to the field and we're going to move this transition range. So as I move this up, we'll see that that effect gets a lot less sort of volatile. We can see it's still pulling into that sphere, but it's not as aggressive. Going back to my strength, maybe let's turn that down to a 1. And now we'll start seeing that things are moving a little bit more sort of fluidly. One more thing I want to do is I actually want to reverse, or have the potential to reverse, the polarity of this force. So right now it's pulling towards. I actually want to push away. So between my field and math mix, what I'm going to do is insert a math operator, and under this input attribute scope, I'm going to turn it to weight. And now I have this handy multiplication that I can actually use to really either amplify my weight or do something like minus 0.25. And what we'll see is that things sort of push away a little bit. So we can see that's kind of like a super nice effect. I probably should at this point also go into my field and let's match that to our sphere, which I believe is a size of 1. And again, as you turn things down, you could also theoretically turn other things up to make that effect sort of more obvious. So we can see here that elements are sort of being pushed away from our attractor. One more thing I want to do is I want to add a bit more dynamic movement to our attractor, and I want to create a noise chop, a second noise chop. Plug it into a null as well, just so we have a scale null if we want to scale it. And we'll go and make this into a time slice. I'll just call it size. And I'm going to drag in this value to my radius. Actually, let's do it to the uniform scale, so it's just 1 value. And again, that's moving very, very fast. So let's turn that down to a period of like 6. And let's keep the amplitude at 2 with an offset of 1. And now we can drag this up to our field and apply this to the radius. So this should match whatever the size of our object is. So there we see as it gets bigger, it gets more effective, and as it gets smaller, we see less of its effect. This is great. What I'm going to do to make this reusable multiple times is I'm going to encapsulate all this stuff. So basically this field, this math mix, and also the visualizer. So I'm going to select all of this and say collapse selected, and I'm going to call this A1. We have this sort of modular attractor component, and what I can do is start parameterizing it before I copy it to be used multiple times. The first thing I'm going to do is inside the component, I'm going to right click and say customize parent component, and then I'm going to start dragging in the things we want to sort of parameterize and work with. The first thing that we might want to work with is this noise amplitude. So I'm going to drag this in. I'm going to say bind par as new master. We'll do the offset as well. And this is going to essentially create a control panel that we can use. Something else I'm going to do is for both of these noises, I'm going to set the seed to parent.digits. So parent with these brackets dot digits. And what this is going to do is it's going to allow us to take whatever the parent value is and set the seed. This is going to allow us to have different values set for each of these attraction visualizers. So that's a handy way to make sure that all of our attractors are moving in different positions without having to go in and internally move stuff. I'm going to go in and also just bring out these periods. You can be creative with what you bring in, just basically anything you want to work with. Good idea to sort of label things. So we have this amplitude, which I think is size offset. So for the label, we can call it whatever we want. This first period, I believe, is noise 1 period. Noise 2 period. So we've got that sorted out. We can go in and parameterize this transition range as well. That's already kind of going to be labeled. And we also might want to work with this multiply. So we can just say weight multiplier. And I'll make this available on my Patreon as well, so folks can use this if they don't want to sort of build out this component. So going out, let's see what we can do with this. So I'll go into here, so I can turn up the size. I can turn up that size offset as well. Just have that at 1. Can move the period so it can move faster and slower. And turn up and down the transition range, as well as that weight multiplier. So you can have each of your attractors having a slightly different weight. One more thing I want to sort of do before I output this and start copying this multiple times, is I want to create a sort of a bit of a feedback loop to allow things to bounce back to their original positions a bit slower. What we can see here is when we apply this attractor, the particles are moving to it or away from it when it's in their vicinity, but it's not kind of sticking and sliding back. It's a bit jumpy. What I want to do is create something that sort of accentuates the time it takes to get back to that starting position. And a way I like to use to do this is using a feedback. So I'm going to drop in a feedback in my component after the in, and I'm going to set my null right here. So after the in, we have our field, we have our math mix, and then we have our null. I'm just going to position things like this so we can kind of see that. And we can see that as we move that attractor through, it's essentially pushing these tentacles into these new positions, and we have lost a lot of movement because we don't have that underlying noise anymore. We just have that one feedback element. I'm going to set up a keyboard in. Well, actually, we're going to go back to our customize parent component. We're going to output this start so we can control it with a keyboard in. We'll do that externally. And the other thing I want to do, which I'll parameterize in a second, is I want to create a math mix at the end of the chain just before this null. And I've done this effect quite a few times in my tutorials now, but basically this is kind of a mix between two sets of values. So we're going to have our affected value here, which is basically all these values that are being fed back and are being repositioned. And we're going to pair it with this original value, which is essentially where we want to return to. And the effect I use here is mix. So mix A, B, and C. Whoops. I'm going to say P for position. Ooh, I want to do mix A, B, C, not max. So P for position. So this is our affected position in the first input. And then in 1P is our unaffected position. And then the third value is basically a mix value that we can use. So 0.5 is somewhere in between. Let's see as it goes up. There you go. So at 0, it's going to fully push things away. And at something small like 0.05, it is going to return to its original position, but it's going to take longer for those particles to sort of bounce back. Do you see how it sort of has more of a slide? And the lower you go, the longer it takes for those sort of values to reset. So this is something that you can obviously sort of play around with. And what we might want to do here is create another parameter that we can actually manipulate from outside of the component itself. So I'm just going to call it mixVal. We'll put it down to 0.01. Let me bring up my component editor again. We'll drag that in by new par. Mixval. And instead of this hard written value in scope C, I'm just going to go in and say mixval. So now I can control it externally. C0, full manipulation. One, we move back. So you have a bit of control over these effects here. Okay, so what we've done now is we basically have this modular attraction component, and what we can do is we can copy it. So I'm going to copy it 1, 2, 3, 4 times, and we want to chain this. So basically each one of these is affecting, based on wherever the position of its attractor is, it's affecting the position field that we're feeding in. So what we want to do is we want to take this top layer, which is our position for the attractor field, and just plug it in like this. And then we're going to take not like that. And then we're going to take the final output, attractor 4, plug it in there, and we should be able to see multiple attractors in motion. For visualization purposes, we have this visualization of these spheres as well, which basically correspond to the attractors. So we can just plug all these things out into a merge as well. And so now we can see our field being manipulated by all of these different attractors. And you could go in and make kind of control changes to all of these individually. So you can have a bit more sort of control over this whole system, which I think is really cool. If you wanted to make this system even more modular, you could just put this into a replicator and program the output connectors to go into each other in this sort of way that we have here, so sort of daisy chaining. But for me, I think I kind of tap out at wanting 4 or 5 attractors anyway, so this kind of manual method is very good for me. At this point, we can choose whether or not we actually view those top layers, so we can kind of go in and just have the attractors without those top layers as well. We can probably see that I've kind of amped things up quite high over here, so we could sort of turn things down to something that's a bit more manageable. But this is sort of the effect. And finally, let's just add in that keyboard in chop that we can use to control all this stuff. So let's set that to pulse. So now when we press that keyboard in, it should set it up to just reset that network. Yeah, I'm sticking with those minus weights. Now we have set up these attractors, I want to start adding in those little particle trails to the top of some of these tentacles. And to do this, we really have to think about these lines as a series of points. We can see if I look at my line here that it has 18 divisions, so that's going to be 18 points per line. And basically I want to get the index of these points so that essentially I can delete everything except for the last point. And to create that attribute, we could go ahead and do a math mix and go into A just to create a new attribute and say point I. So this is going to give us the point index. Let's just bring that out and look at this in a chop. You can see that this has created an index. But another way we can do this, which probably is a slightly more elegant way, is we're going to go in and use the line metrics. And under the index, we can go to vert index in line strip. And so now, if I drag this out, again, we're going to get an error. But let's look at that attribute. And we can see that we have the number of points in our line. And so this is going to be really useful for later, because basically what I can do is after I've processed all of this data to create my attraction points and all that stuff, basically once I've got to this point where everything is processed in terms of position, I'm going to drag this out into a delete. Basically at this point we have created all the position information that we need, and we can just delete the bits that we don't need to access the top point of each of these tentacles. So if I go in, I should be able to see under attributes that my vert index is available. And let's just go back quickly to our line and let's see how many points we have. So we've got 18 divisions of our line. So I'm just going to use that as a reference here for our value. So we can see that a bunch of stuff has just got deleted. And let's bring this out into a chop so we can actually see what's happening. So we can see that even though we actually can't see a visual right now, there is data here. And this is basically because we are left with a single point. If I bring this out into a trail, we're going to start visualizing these points over time. And this is something that I like to sort of add into my mix. So let's just put this into a geo. Zoom in so we can see a little better. So we can see that all of these tentacles have some kind of point attached. Now I want to take this a little bit further, and I actually want to only visualize tentacles that are over a certain height when it comes to their points. So I'm going to do another attribute operation in my delete. So I'll press this plus button, and I'm going to look at my color 0. So then I can move between, and maybe this is too many, but let's do smaller or equal then. Let's press that as well. That's just because of the glitchiness of the trail there. And so this should be doing it based on the color value, which kind of relates to the height. You can see here that if I move this up a little bit or down a little bit, we get these different effects. Let's see. There we go. So now only certain operations here are going to be maneuvering because of that height parameter. And what I'm also going to do, just to make that not sort of do this glitchy thing every time I hit my feedback, is I'm going to take my keyboard in and I'm going to add that to the reset pulse on my trail. So now every time I reset, we're going to reset without creating that weird extended trail effect. And so this is something you can play around with in the delete in terms of how much stuff you want to actually sort of visualize. We can also see that if we view it without the background tentacles, we get a sort of a completely different output for the visual. So this looks more like some sort of like attractor field versus something a bit more organic. This is going to come into its own when we start rendering. And what I want to do here is I want to have two separate renders. So I'm going to create another render here, and render 1 will be my geo 1. So this will be the tentacles, and this is going to be my geo 3. Not geo 2 because we've already instanced these attraction positions. And what I'm going to do here is I'm going to basically combine these together after doing some various operations. Let's bring that in, and let's set this to screen for the time being. You can play with that later. I'll start off with render 2. We're going to add in bloom. And let's just look at render 2 right now before we get into combining them. I also, when I work with bloom, I like to turn down the input image so I can kind of work with the values that I'm putting in. So let's turn up some of these things like the gamma and the brightness. That bloom radius turned down. It's getting kind of nice. Okay, that's getting quite good. Let's see what it looks like closer in. So it's starting to look sort of a bit psychedelic, which is good. That's kind of what we want. Now let's take a look at how that looks combined together. And it's making the tips of those tentacles really pop, which I like a lot. I also want to even out the tentacle vibe just a little bit. It's a bit harsh for me right now. So what I'm going to do is I'm going to add in a blur, and I'm going to ramp that blur up quite a bit. And then I'm also going to add in a screen, combine those together. And that just sort of creates a little bit of softness on the tentacles there. So it's not quite as abrasive as before. You could go a step further and add in a little bit of bloom as well, or instead of. This is really to your personal taste. So let's just see that though in action. Just this RGB key. It's too much. Turn down that gamma. Have a big bloom radius. Like that. Just make it a little bit more pervasive. Let's see what it looks like without the blur screen. Yeah, so the blur screen really adds a lot of texture there that we can use later in this bloom. So let's turn that all on. Play with this direct feed. And let's bring this back into the comp so we have both. So now we have something that is quite sort of ephemeral, which I think is a super, super nice effect. And this is basically the tutorial. For Patreon subscribers, I'm going to run through in a separate short video how we can attach camera automation to this. So if you're interested in creating something that moves and pans around automated by a sort of custom camera path, sign up to the Patreon to see how to do that. But this is the end of part 2 of this tutorial. I hope you've enjoyed it. I'm going to be posting a few more tutorials in the coming weeks on really cool things we can do with pops. And I look forward to seeing you soon.